Hello viewers, in this session we are going to discuss the domain of this function f of x that is equal to logarithm of x over 2 to the base 1 minus x square, right? So here we have to find out all the values of x for which this function is defined, or we have to find out all the valid values of x for which the given function is defined, right? So here what we will do, we have this function in the form, say log of, say here we have p of x and here we have q of x, and suppose here we have the function f of x, right? So whenever we have a function like this, then here we have logarithm of p of x to the base q of x, and in order to get the domain of this function, we have to here write some conditions related to p of x and q of x. So we have to impose some constraints on p of x and q of x, and here the conditions are p of x should be greater than 0, and q of x, that is the base, it should also be greater than 0, and moreover q of x should not be equal to 1, right? So the domain of this function is given by these conditions, right? P of x should be greater than 0, q of x should also be greater than 0, and the base, that is q of x, it should not be equal to 1. So here let us first compare this function with this one. So we have p of x is equal to x over 2, then q of x is equal to 1 minus x square, right? So here applying these conditions to these two functions, we must have x over 2 greater than 0, and then we have 1 minus x square should be greater than 0, and then we have 1 minus x square should not be equal to 1. So now we have these three conditions, right? Now from condition 1, that is from this inequality, we can straight away write x greater than 0. That is multiplying both sides by 2. We have x greater than 0. And from here, we have 1 minus x square greater than 0. So this implies that x square should be less than 1, right? And from condition 3, we must have here, that is x should not be equal to 0, right? Because 1 minus x square should not be equal to 1, so x should not be equal to 0. So now let us plot these three conditions, or represent these three conditions on the real number line. So now here we have the real number line minus infinity, here we have plus infinity, and here we have x greater than 0. So here we have x is equal to 0, and x greater than 0 implies that x belongs to the interval that is 0 to infinity, right? So here we have this region which represents x greater than 0, and remember here 0 is not included, right? So here we do not have x is equal to 0. Now from this inequality, that is x square less than 1, we can also write this inequality as x square less than 1 square, right? So this inequality is now of this form: x square less than, say, a square, and the solution of this type of inequality is given by x greater than minus a, and less than positive a, or we can write x belonging to the interval minus a to a, right? So here we have a is equal to 1, right? So we can here write x belonging to the interval minus a to a. So here we have minus 1 and we have 1, or we can write x greater than minus 1 and less than 1. So here we have minus 1 and here we have plus 1. So x square less than 1, it can be represented like this. So here we have this region, and remember x should not be equal to minus 1, and x should not be equal to positive 1, because this is x square less than 1. And here the third condition is that x should not be equal to 0, right? Because x is equal to 0 makes 1 minus x square equal to 1. And here 1 minus x square should not be equal to 1, right? So x should not be equal to 0, which is already included in this condition. So now we have this situation, and we have to now extract the domain of this function by taking the intersection of these three conditions, right? So we have to identify the common region that is which belongs to these three conditions. So here we can easily see that the common region is from 0 to 1, right? So here we have the common region 0 to 1, and remember, so here x should not be equal to 0 and x should not be equal to 1. So the common region among these three conditions is given by 0 to 1, right? So the domain of this function, that is f of x, is given by this interval, that is x belonging to 0 to 1, and this is an open interval, and here the endpoints are not included. So we can also write this interval as x greater than 0 and less than 1. So this is the required domain of this function. And remember, here we have x greater than 0, x square less than 1, and x should not be equal to 0. And when we have represented these constraints or conditions on the real number line, we have here 0 to infinity, 0 to infinity. Then we have x belonging to the interval minus 1 to 1, minus 1 to 1, and x is not equal to 0, right? So when we identify the common region, or we when we take the intersection of these three conditions here, the common region so identified is this interval, that is 0 to 1, and the endpoints, that is 0 and 1, are not included. So this is the required domain of f of x.